Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tripology subject. In previous sessions, already we have discussed about engineering materials. So some materials already we have seen. So remaining materials, the ceramics and the polymers and its applications we will see in this session. So already you know about engineering materials. So these are the fundamental substances used in the construction and manufacturing of various products and structures. So these materials are selected based on their properties and suitability for specific applications. So before designing any component, so before manufacturing the product, the selection of material is very important, so that the material selection based on their properties. So what are the important properties are there, like mechanical properties, electrical properties. So that property depends upon the application of your product. So that every engineer, you should know about these properties. So without knowing properties, you can't manufacture and you can't design. So that's why from everyday objects to complex industrial components, the material selection is important. For our daily life used products to complex products used in industries. The field of engineering materials encompasses a wide range of substances, including metals, polymers, ceramics, composites, and semiconductors. So already we have studied about these metals and polymers. So the materials, the property is plays important in the manufacturing process, like the machining and the forging. That's why you should select the particular material for particular application. If you don't know the nature of the material property, so suppose you have used wrong material for right application, it gives failure design. So that you should knowledge about all materials and its properties. So in this part, the ceramics are non-metallic materials. So materials are again classified into two types. One is metallic and non-metallic. Already you know. So now in this session, we're discussing about this ceramics. So ceramics are non-metallic, inorganic solids that are typically made from clays and other natural materials through a process of heating and subsequent cooling. So by using this heating process and then immediately the subsequent cooling process, made these type of ceramics. So originally from clays and other natural materials. So whenever heating and whenever cooling, so it gets some properties, and then you can made the desired of the materials. They have crystalline or partly crystalline structures and are often brittle but hard. So brittle in nature and then but hard material. So brittle properties and hardness and ductility, these all are the mechanical properties. The structure, the crystalline structure of the metal, the atomic structure, very very important for metal. Already we have seen in engineering materials introduction part. Next, properties. So what are the properties of ceramics? So these materials have high hardness and strength and high melting points and good thermal and electrical insulation. So these are the melting and hard and strength and the thermal and electrical applications properties are very important in the mechanical products. Chemical and inertness and brittle and prone to fracture under stress. under stress it is withstand or not. You should check before using before selecting the materials. So all these properties very important for ceramics: the high hardness and strength, the high melting point, and good thermal and electrical insulation, chemical inertness, brittle and prone to fracture under stress. So what are the applications? So the applications of the ceramics are in the field of construction. In construction, so many applications are there. So they are used the ceramics materials, and so like bricks and tiles. The ceramics, bricks and tiles used in building construction for walls. So nowadays all are using these tiles and bricks, the ceramic tiles, roofs, and then flooring due to their durability and aesthetic appeal. So the look wise and then the durability, these are suitable for flooring and for walls and roofs. The bricks and tiles. Next one is cement and concrete. The essential components in construction for making structures and buildings. The cement and concrete are one of the applications of these ceramics. Next one is household applications. So tableware. The tableware items like plates, bowls, cups, and other kitchenware made from ceramics due to their hardness and ease of cleaning. The cleaning is easy and the hardness property. So and look wise also very good appearance. So that's why the tableware items are these all are comes under household application, the plates and bowls. You can see in our daily life the ceramics products we are using. Cookware items like the baking dishes and cookware are made from heat resistant ceramics. So heat resistance, it can resist the heat. And then industrial applications. So industrial applications are refractories used in furnaces, kilns, and then reactors due to their ability to withstand high temperatures. So they do withstand the high temperature refractory materials used in industries. Abrasives. So materials like silicon carbide and aluminum oxide are used as abrasives for cutting, grinding, and polishing. So these are the major applications in industries. Industrial related applications are refractories, materials, and abrasives. So in medical field, dental implants. Ceramics like zirconia are used for dental implants due to their biocompatibility and strength. The bone substitutes. The substitutes are bone substitutes used in orthopedic applications for bone repair and replacement. So whenever required the bone repair or bone replacement, so there these type of ceramic bone substitutes are used. Whereas in dental implants also like materials, the zirconia used for dental implants. So due to its compatibility, biocompatibility and strength. So next electronics. Electronics capacitors. Ceramic capacitors are used in electronic circuits for their excellent electrical insulation properties. And similarly, insulators. So insulators used in electrical power lines and other electrical applications due to their high resistance to electricity. So these are the major applications in electronics. And aerospace, the thermal barrier coatings. So thermal barrier coatings, these ceramics are used to coat engine components and protect them from high temperatures. Structural components. High strength ceramics are used in various structural components of spacecraft and aircraft. And art and decoration, pottery and sculptures. The ceramics are widely used in art for making decorative items and pottery and sculptures. So the decorative purpose items, a lot of items are made with this ceramics material. So finally, the ceramics are versatile materials with a wide range of applications due to their unique properties. From construction and household items to industrial, from construction and household, the daily life used products to industrial complex products and medical and electronic applications. Ceramics play a crucial role in various fields, contributing to advancements in technology and improving the quality of life. So these are the important role of ceramics in engineering materials. Next one is polymers. So polymers are large molecules composed of repeating structural units, so called as monomers, connected by covalent chemical bonds. They can be natural, like cellulose and proteins, or synthetic, like polyethylene and nylon. Polymers exhibit a wide range of properties and can be engineered to meet specific needs. So, like polyethylene and nylon, these are the polymer materials. So, due to the repeating structural units, the large molecules will be formed. So, that's why the composed of the repeating structural units are called as monomers, connected by the covalent chemical bonds. So, that's why these polymers are exhibit a wide range of properties to meet the specific needs. Just the properties of polymers. One is lightweight property. The polymers generally have low densities, making them lightweight. Corrosion resistance. They resist corrosion and degradation by chemicals, making them durable in various environments. Flexibility. Many polymers are flexible, which allows them to be modeled into different shapes and forms. Next, thermal and electrical insulation. So polymers often have low thermal and electrical conductivity, making them good insulators. So low thermal property is required for these polymers and high electrical conductivity. So that's why these materials are act as a good insulators. Varied mechanical properties. So that is depending on the polymer, they can range from very soft and uh, rubbery to very hard and rigid. So that is the mechanical properties like strength, ductility, malleability, grip. These all properties vary depending on the type of polymer. The cost effective. They are generally cheaper to produce and process compared to metals and ceramics. When compared to the metals or ceramics, it is a cost effective. So that means it is generally cheaper to produce. So metal production is very costly. Similarly, the ceramics also. So what are the applications of polymers? The applications of polymers are: one is packaging. The plastic bags and wrappers widely used for packing food, clothing, and their consumer goods. Bottles and containers. So the packing application, one is plastic bags and wrappers used for packing food, the clothing, and other consumer goods. Similarly, bottles and containers used for beverages, cleaning products, and other liquids due to their lightweight and durability. So the construction, pipes and fittings. Construction in PVC and other polymer pipes are used in plumbing and electrical conduits due to their resistance to corrosion. Insulation materials. Polystyrene and polyurethane foams are used for thermal insulation in buildings. So one is polystyrene, another is polyurethane foams are used for thermal insulation in buildings, insulation materials. So it act as a insulation materials, packing materials in the construction side, in the polymer pipes and PVC pipes used in plumbing purpose. So these are for corrosion, the resistance to corrosion. So they are used in fittings. So these are the major applications of polymers. In electronics, insulating materials like polyethylene and Teflon are used for insulating wires and cables. So Teflon tapes, they are used in electrical wires to insulate and then to resist the corrosion. Flexible circuits used in flexible electronic devices and variable technology. Automotive, the body parts and interiors. So polymers are used to make car bumpers are polymer, and dashboards also polymers, the body parts and interior parts of the automotive cars. And interior panels due to their lightweight and impact resistance. Fuel systems. The fuel systems like polymers like nylon are used in fuel lines and tanks. So these are the electronic and automotive related applications of polymers. Next, consumer goods. In consumer goods, one is toys and household items. So many everyday items like toys, kitchenware, and furniture are made from polymers. The sporting goods. Polymers are used in equipment like tennis rackets, helmets, and protective gear. Next, agriculture related applications. Greenhouse films. So polymers like polyethylene are used to create greenhouse coverings. And irrigation systems. Polymers are used in drip irrigation tubes and systems. So all these in this way, the agriculture field and from the sporting goods and electrical field and construction, the polymers are used. So that finally the polymers are incredibly versatile materials that have revolutionized many industries. Some revolutionized occurred in industries due to these polymers. Their wide range of properties and ability to be tailored for specific applications make them invaluable in everyday life and advanced technological applications. From packing and construction to the medical and electronics, the polymers play a crucial role in modern society. So that we should learn the properties of materials like ceramics and polymers and what its applications and their properties we should know before going to make product before designing any product. That is selection or depends upon the selection of materials. So then only your product will be success in the outside market without failures. So to avoid failure, to avoid corrosion, to avoid friction, to avoid wear, you should use the proper materials for proper application. So that's why in industrial engineering, in engineering tribology, you should concentrate on engineering materials properties. Similarly, the corrosion. Corrosion also we have studied in the previous sessions. And the main parameters are friction, wear, and lubrication. So the subject revolves around these three topics only, the engineering tribology. So whenever you got good knowledge in this friction, wear, and lubrication systems, and then these corrosion material properties, then you can apply you can apply and you can select the proper materials for proper applications. So without no failures, the results will be occurred. So that's why every engineer you should learn about engineering materials. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.